This video is going to look at how we can go about converting rectangular and polar coordinates. To start out with, if we have our rectangular coordinate system, we know that we have our x and our y axis here. And if we think of this in terms of our point, we can have a point located here as far as this would be our x and y coordinate. And we can think about getting there if we were to look at a right triangle. We would know that we would have this would be a distance x that we go, and this would be a distance y. And of course, we could think of that as x squared plus y squared equals the hypotenuse here, which we could think of that as r. So if we think of this as r, then we know that we have our directed angle here as theta. So to get to this same point here, we could look at it in the polar coordinates r comma theta, where we rotate an angle here and go out the distance r. And we could think of this point as well as x and y. So how can we convert this? Well, we're going to use our trig functions, where we can use the idea that we know sine of theta, if we recall, is equal to y over r, okay? And if we rearrange this, we can multiply by r on both sides to get r sine theta equals y. So we could think of this as y equals r sine of theta. And then of course, if we think of the cosine function, cosine theta is equal to x over r. And again, we could multiply both sides of the equation by r, and we would get x is simply equal to r cosine theta. And we also know that the tangent of an angle is equal to y over x. And using the Pythagorean theorem, we know that r squared is equal to x squared plus y squared. So we're going to look at using this. We're mainly going to be using these three here, and we will also use this idea of the tangent. Theta is equal to y over x. So looking at this, we can kind of see the relationship that we have here. Over x and y is our rectangular coordinate, and we can get to this same point by rotating around some angle theta and going out the directed distance here of r out to this particular point. So let's look at how we can use the formulas that we have over here to actually convert the following point. So if I was given a point 4 comma negative pi over 3, and this is r and theta, and we want to convert this to rectangular coordinates. So that means we want to get rid of r and theta, and we want to convert that to x and y. So to do that, we're going to simply use the formulas up here, and the main focus right now is going to be on these two here. X is equal to r cosine theta. Well, if x is equal to r cosine theta, we know r and we know theta. R is 4, theta is a negative pi over 3. So we could simply just say, using x equals r cosine theta, we would have x is equal to the r value of 4 multiplied by the cosine of the angle negative pi over 3. Now, as we convert this, or maybe before I go any further, actually converting it, we should probably locate, just to be safe, we want to locate the coordinate for negative pi over 3. So if we were to plot that point, we're going to rotate negative pi over 3, so we're going to go down, if it's negative, so we're going down this way, a negative pi over 3. And that would be located right about here if we went around a negative pi over 3. And we're going to go out a distance of 4. So really, if we go here, a negative pi over 3, and then out a distance of 4. Now, we don't have to be extremely accurate. I just want to make sure that we know that we're going to be located here in the 4th quadrant. So now, when we go to do this, we're going to get x is equal to 4 cosine negative pi over 3. Well, this point, if we think of the unit circle here, where is this going to be located? if we go to our unit circle, if we're at this point here where we have rotated down a negative pi over 3 on the unit circle, the x and y coordinates here would be 1/2 and negative square root of 3 over 2. Now, because this negative pi over 3 is actually on the unit circle, we can use here the exact coordinates to get the exact answer, because we know here we have your x and your y. So we could take 4 and multiply that by the cosine of a negative pi over 3. Well, the cosines are x, so that would simply be 1/2. So then we get an exact answer of 4 times 1/2, which is going to be equal to 2. So we have x is equal to 2. Now, again, if the negative pi over 3 is not on the circle, we could have certainly went to the calculator and simply used our cosine function to find it. Now, because we're dealing with radians here, you want to make sure that your calculator is in radian mode if you decide to do that. So if we can, let's use the exact answer. Now, to find the y value, we would simply use y equals r sine of theta. So that means we have the r value of 4, and now we're going to take the sine of the angle negative pi over 3. And here we see that the sine is the y value, so that's going to be equal to 4 times a negative square root of 3 over 2. And if we multiply that, we can end up with a y value is equal to a negative 2 square root of 3. So therefore, your x coordinate would be 2, and the y coordinate is negative 2 square root of 3. So we now have converted this from polar to rectangular. Now, let's kind of verify that that is correct. If we have a positive 2, that means we would go over 2 and then down a negative 2 square root of 3, and that seems accurate to get us at this same point as the polar coordinate for negative pi over 3. All right, if we look at the next example here, and again, you want to pause the video and see if you can work this out on your own. Let's say that we're given, in this case, the point 1.5, comma 3.67. And once again, this is in terms of polar coordinates, r and theta, and we want to convert this to rectangular, which means we want to convert this into x and y. So again, pause the video and see if you can do this one on your own. Now, once again, before we go any further, I want to actually plot this point. Now, we know that if we go, this is 0, and this would be over here at pi, which would be an angle of 3.14. So the angle of 3.67, we know is going to roughly be here. Theta is equal to 3.67. And r is equal to 1.5, so we're going to go out r is equal to 1.5. So we know we're going to be over here in the third quadrant. So that way we can kind of check to make sure we find the right x and y coordinate. So once again, we're going to use x equals r cosine theta. So that means we're going to take r value of 1.5 cosine of 3.67. Now, we can't go to the unit circle and find the cosine of 3.67, so this is where we would go to the calculator, type in 1.5, and then we want to multiply that by the cosine of 3.67. And if we hit enter, we get a negative 1.295. So I'm going to round that to a negative 1.3. So x is equal to a negative 1.3. And if we do the same thing for the y, in this case it would be r sine of theta. So y equals 1.5 the sine of 3.67. So if we go to the calculator, we would go, let's clear this out, 1.5 sine of 3.67. And we get a negative, and I'll round out to a negative 0.76. Negative 0.76. So therefore, we would have a negative 1.3, comma, negative 0.76. And let's see if that makes sense for rectangular. Well, negative would go here. So this looks like a negative 1.3. And then we're going to go down to get to this point, which looks like this could be a negative 0.76. So therefore, this would be our x and y coordinate for the polar coordinate 1.5, 3.67. So these two examples here, we've looked at converting from polar to rectangular. And now we want to look at what happens if we're given the rectangular coordinate, such as the point 1, 1. And we want to convert here, this is our x and y, and we want to convert this to polar form, which means we need r and we need our angle theta. Well, in order to do that, how do we find r? Well, we know that, well, let's go ahead and plot this first, just like before. We want to plot the coordinates, so we know we're going over 1 and up 1. So we know the point here is in the first quadrant. So how can we find r? Well, we know that r squared is equal to x squared plus y squared. So if we substitute in, we have x and y, so we would have r squared is equal to 1 squared plus 1 squared. So that means r squared is equal to 1 plus 1, which is 2. So that means r is equal to, we need to take the square root of both sides. So when we do that, remember we would technically have plus or minus, so we would get r is equal to a positive or negative square root of 2. And then we need to find the angle. So if we go to find the angle, we know that tangent of theta is equal to y over x. And if we use the inverse, that means theta is going to be equal to the inverse tangent of y over x. So for us, then we would take theta is going to be equal to the, inverse tangent. Sorry, got the little negative one here. So this would be the inverse tangent of y over x. So the inverse tangent here would be our y value of 1 over 1. So that's simply 1. And again, we could go to the unit circle and find this. If you think of our unit circle, where do we have y over x is equal to 1? Well, if we look here in the first quadrant, that's going to occur here at pi over 4 because the point here is square root of 2 over 2 for the x and square root of 2 over 2 for our y. And we'll notice that even down here at 5 pi over 4, we have a negative square root of 2 over 2 and a negative square root of 2 over 2 for your x and your y. So either one of those points, the angles rather, would give us 1. So I'm going to go ahead and just look at the positive pi over 4. So the angle is pi over 4. So it looks like we would have r is equal to square root of 2, and the angle is pi over 4. Well, if we rotate around pi over 4 and we go out square root of 2, it looks like we would get to that same point here in the first quadrant. Now, if we decided to use this negative, and if we use the pi over 4, then we could have said, well, let's use a negative square root of 2 and the angle 5 pi over 4, because if we went all the way around here, this would be 5 pi over 4 facing this direction, but we want to get up here to this point, so if we went backwards a negative square root of 2, that would put us here at the same location. So here we could actually use either one of these answers, and once again I would typically use the positive angle, so I would probably go with this first one where we have a square root of 2 comma pi over 4, And keep in mind, this again is r, and this is the angle theta, which is the same location that we found up here for, was given rather, 1, 1 over 1 up 1 in our rectangular coordinate system. So in terms of x and y, it's 1, 1. In terms of polar r theta, we could use square root of 2 and pi over 4. All right, one more example, and this one I'm going to look at using -1 comma -1. And again, this is x and y, and we want to convert the rectangular into polar, which means we're looking for r and theta. So once again, you may want to pause the video and see if you can find this on your own. And just like we did before, I want to go ahead and plot the point. We're going to go -1, -1. So we're over here. And now we're going to still use r squared equals x squared plus y squared. So r squared is equal to -1 squared plus -1 squared. So r squared equals 2. And just like before, we would end up with a plus or minus square root of 2. And if we go to find the angle theta, we know theta is going to be equal to the inverse tangent of y over x. So for this one, we would have the inverse tangent of -1 over -1, which would be +1. And if we were to put this into the calculator, we know that we're going to get an answer, and that answer here would be pi over 4, because remember, when we use the, one thing we have to go all the way back and remember is when we use the inverse tangent, our answer is always going to be from -pi/2 up to a +pi/2. So we're only going to get an answer in the negative fourth quadrant or the positive first quadrant when we're using the calculator, but we know that our angle is all the way over here in the third quadrant. So we know that we're going to get an answer here from before that is going to be located at pi/4, or down here at a positive 5 pi over 4. And if we went with the pi/4, we could certainly do that. But if we go with 5 pi/4, we know that our point needs to be over here. We would have to use the negative square root of 2. So we could use a negative square root of 2 and pi/4, or we could actually use a positive square root of 2 and the angle 5 pi/4, because that means we would rotate all the way around here to 5 pi/4, and then we would go out a distance of a positive square root of 2. So once again here we would have not just these two, but we'd still have infinite possible answers. But here are two possible answers for changing your rectangular coordinate to a polar coordinate, where this is r and theta. So if we're converting from rectangular to polar, then you're typically here going to use r squared equals x squared plus y squared to find the r value, and you're going to use the inverse tangent of y over x to find your angle. Now just make sure that you pair up the right angle and the right r value to get to the same location as your xy point. And if we go back up here, if we're going to convert from polar to rectangular, then you're going to be using x equals r cosine theta to find your x, and you'll be using y equals r sine theta to find your y value.